Hello, discrete math fans. Let's do some examples involving transitivity. I'm going to create a set A, which just has 1, 2, 3, 4, and I'm going to define the relation R to consist of these ordered pairs. And the question is R transitive? Prove or disprove. All right, this relation is not transitive. As usual, to prove that it's not transitive, we'll exhibit a counterexample. We can see that 2, 1 is in the relation, and 1, 4 is in the relation, but 2, 4 is not in the relation. So if we're going to have 2, 1 and 1, 4, then we have to be able to go directly from 2 to 4, and we don't have that. That means this relation is not transitive. I'd like to visualize this with an arrow diagram. This is the relation that we showed at the beginning. You can see that there is an arrow that goes from 2 to 1, and then an arrow that goes from 1 to 4, but what you don't see in here is an arrow that goes directly from 2 to 4. There's actually one more counterexample in here. Can you find it? A little tricky to come up with at first. Let's do another example. I'd like to define the relation S on the integers by saying that for A and B in the integers, A is related to B provided 7 divides 2A plus 5B. Is this relation transitive? We'll prove or disprove. All right, so it turns out that this particular relation is transitive, and so let's prove it. Let's let A, B, and C be integers, and we'll assume that A is related to B and B is related to C. Remember that transitivity, like symmetry, is an if-then statement. And so we always want to start by assuming the if part. All right, so this means that 7 divides 2A plus 5B. 7 also divides 2B plus 5C. That means there are integers j and k, so that 2a plus 5b equals 7j, and 2b plus 5c equals 7k. So just following the definition of divisibility. Our goal now is to prove that a is related to c. That is, we want to prove that 7 divides 2a plus 5c. We're going to do a little bit of algebra here. Let's take 2a plus 5c, and let's add in 5b plus 2b. And of course, you can't just go around adding 5b plus 2b anywhere you want, so we'll compensate for this by also subtracting off 7b. Let's group these now. And now, according to our assumption, 2a plus 5b can be written as 7j, and 2b plus 5c can be written as 7k. And of course, we can factor out a 7, and that makes 2a plus 5c divisible by 7. Since 2a plus 5c is divisible by 7, that means a is related to c. And so we have proven now that this relation is transitive. All right, here's another fun fact. This particular relation is also reflexive and symmetric. You should try to prove that fact. Let's do another example. Let's suppose we have an alphabet with 0 and 1, and let's let S be the set of all finite bit strings. Think of this as the set of binary numbers. Not exactly, because we can also have the empty string, but pretty close. I'd like to define a bit flip relation. We're going to say that for any strings u and v, u is related to v if either they're the same bit string, or we can get from u to v by flipping a single bit. And the question is f transitive? Prove or disprove? Now, before we try to answer the question, let's just make sure we're clear on what's in the relation. We can say that 11001 is related to 11001 just because they're the same bit string. We'll also say that 11001 is related to 11101 because they differ in just the third bit. However, 101100 is not related to 110100 because these two strings differ in two places. We can see that these two bit strings differ in the second and third places. Now, if necessary, let's go ahead and say that we can always pad with zeros on the left. So we're going to say that 11001 is also related to 1001 because we can go ahead and think of 1001 as being the same as this. All right, we're ready to prove now that this relation is actually not transitive. And let's exhibit a counterexample. That's what we always do if we want to prove that a relation does not satisfy one of these properties. Well, pretty easy. 0, 0 is related to 1, 0, and 1, 0 is related to 1, 1. In each of these pairs, you can get from one to the next by just flipping a single bit. However, 0, 0 is not related to 1, 1. Those two strings differ in two places. Therefore, this particular relation is not transitive. Fun fact, it is reflexive and it is symmetric. It would be worth it for you to try to prove that. Okay, that's all for now.